So this is our Bayesian network, or we can also say belief network. This is actually a directed acyclic graph or DAG that represents a set of variables, their conditional independences, and quantitative probabilistic information. For example, here we have the probability of strep throat. We will denote strep throat as S, fever as F, and sore throat as O, and strep test positive as L. And for the cause, we'll have the prior. For the effects, we'll have the conditional probabilities. So what is prior? Without any other additional information, what is the probability of strep throat? In this case, 0.15. And from this, we can automatically calculate its complement, that is probability of not strep throat. S equals to false means it is not strep throat, right? So we have the conditional probabilities, probability of fever given strep throat, probability of fever given not strep throat. So what is the probability of fever if the patient has strep throat? What is the probability of fever if the patient doesn't have strep throat? We'll have those values. Similarly, we'll have probability of sore throat given strep throat and given not strep throat, probability of positive lab test result given strep throat and not strep throat. And similarly, we can calculate their complements as well. Not fever given strep throat, not fever given not strep throat, not sore throat given strep throat, not sore throat given not strep throat. Again here, negative result given strep throat, we can see that there's only 1% chance, and negative result given not strep throat, all right? 0.95. We can calculate them. So this is our question. What's the probability of having strep throat if the patient has the following symptoms? The symptoms are fever, strep throat, and a positive lab test. What will be our equation? This is our equation. Probability of fever given strep throat multiplied by sore throat given strep throat multiplied by positive test given strep throat multiplied by prior probability of strep throat. We get from here, right? We're just multiplying all the conditional probabilities of the effects and finally the prior of the cause. And now on the denominator, we will have the same thing as the numerator plus also the conditional probabilities of the effects given not cause, where the cause is absent but the effects are present, and finally multiplying by the prior of not cause. All right, this is same as the numerator, and this part will be fever given not strep throat, sore throat given not strep throat, a positive lab test given not strep throat, and the prior of not strep throat. So probability of F given S, we have this one here, F given S. O given S, we have this thing over here, O given S. Then positive test given S, we have this thing here, positive test given S. And finally, the prior of S, we have this thing over here. If we multiply these four, we get this thing. And this will be the same as the numerator. So we copy the same value here. And now we'll also need to calculate the probability of effects given not cause. So fever given not cause, this is our fever given not cause, 0.7. Sore throat given not cause, this is our sore throat given not cause, 0.6. Positive test given not cause, 0.05, this thing here, L given not S. And prior probability of not S, 0.85. All right. So if we multiply these four values highlighted by blue, then we get this thing here, 0.018. Finally, with the calculation, we get 0.86. So that is our result. The probability of strep throat for when all these symptoms are present is around 86%. How about this one? When the patient has fever, sore throat, and a negative lab test, everything will be similar like before. Only in this case, it will be probability of negative lab test instead of probability of lab test. If you compare with the one above, we had like L given S, and now we'll have not L given S, right? Where is it? Not L given S. And similarly, on the denominator, we will have not L given not S. This is our not L given not S. If we multiply F given S, O given S, then not L given S, this is our not L given S. If we multiply those values with the prior, we get 0.001. And if we multiply these values, we get 0.339. All right. What are those values? F given not S, O given not S, not L given not S, and the prior of not S, 0.339. Similarly, in the third example, it is saying we have two symptoms, fever and sore throat, but we didn't test for strep throat. This is our missing evidence. So we just need to consider the information we have. What are the effects? Fever, sore throat, just these two. And what is the cause? Strep throat, probable cause. So if we multiply these three, fever given S, sore throat given S, and strep, prior of strep, then we get 0.18. And the second part of the denominator will be the same symptoms given not cause. Fever given not cause. This is our fever given not strep throat. Sore throat given not strep throat. And finally, prior probability of not strep throat, 0.85. So if we multiply these three, we get this value here. Finally, the result is 0.232. So similarly, you can actually calculate the others here. No symptom, but a positive test result. You can just similarly calculate the other probabilities, all right? If you don't understand, then you can just shoot me an email or visit me in my office hour.